Hi everyone, this is midterm project from group in section 1 who's doing 4-cylinder steam engine. It is done by Gabriel Morgan and myself, Aditi Korat. So project overview. The project consisted of drawings, parts and assemblies, report and a PowerPoint presentation. The work among the team members was divided using a fishbone diagram to also keep the timeline within a set date. We had divided assemblies equally among two of us. There were basically three main sub-assemblies: Assembly 101, 102, and 200, which fell under Assembly 300, which was the final part. Assembly 200 is furthermore divided into 105, which is divided into 103 and 104.
In this slide we have Assembly 300, which is the final assembly. As you can see, we have applied the proper materials given by the original designer, and the challenges we faced was the fasteners throughout this project. We found the fasteners either needed to be changed in length, or even the proper dimensions needed to be found just by going through and checking each of the assemblies once we had all the parts, and going from there and checking for clash and making the proper modifications.
In this slide we have Assembly 101, which is piston sub-assembly. The main components of this assembly were the piston, crosshead, and piston rod. One of the challenges faced while doing the parts of this assembly was the piston rod. The ends of the piston rod that go into the crosshead had a certain threading which was unclear in the drawings given by the instructor, and so we had to figure out the threading that will match with both the parts that the rod connects, and accordingly edit it to make it fit.
Here in this slide we have Assembly 201, which is the main flywheel assembly, where the components are the flywheel, crankshaft, crank plate, roller bearing screw, and the grub screw. Also included in this but not listed is the roller bearing that we had to include, that was not included in the original drawings. It was just an easy fix, simple pad to represent right here on the roller bearing screw, just on the side of it, to allow in further assemblies to rotate properly. Some difficulties we face in this assembly was mostly about the crub screw because of the lack of information. It was not included in any of the drawings that we could see. It was just listed on the part description list, and we had to extend the crub screw in order for the crub screw to meet with the crankshaft, which is going to be talked about further down in the presentation. But once we were able to fix the crub screw, we were able to assemble this together and have it move properly. So as I was saying before, the crankshaft, we had to go through and add a hole to allow the crub screw to insert into the crankshaft, so that when the crankshaft would rotate, the flywheel would also rotate with the crankshaft. Without this modification, the crankshaft would rotate and the flywheel would remain stationary. Also, it is important to note, when we were going through and creating these holes, the proper dimensions were incorrect, and we had to use other parts such as the crank plate to make sure we had the correct diameter, and from there we were able to make everything fit together with no clash. Also, for Assembly 200, this assembly was relatively simple to put together. It was just the main thing you had to make sure was that the pipes lined up, and in order for that to happen, we had to extend the pipes just slightly. I think it was 3 millimeters, and that was to make it fit properly into the bottom part down here. But other than that, the fasteners had to be extended, or they didn't have to be extended, but we deemed it necessary to extend the fasteners in this upper plate right here in order to have to provide more thread space for the screws. As I said, it's not required, but it was just to make it fit together a little bit better. Also, this is assembly 105. It's similar to the previous assembly. It just has the components of subassembly 103, 104, the crankshaft bearing, the cylinder inlets, and the countersink fasteners. It's important to note that the countersink fasteners had to be modified in order to fit. If we did not modify the countersink screws, they would have collided with the main part of the crankshaft bearing, so that was a minor problem we had to fix when we were assembling. And also, for, like I said earlier, the cylinder inlet pipes had to be increased in order to fit inside the crankshaft bearing, and without that additional length they still fit, but they were just right on the edge, and we deemed it necessary to extend the pipes for it to be a better design.
So crankshaft bearing is one of the parts in the previous assembly. As you can see, this was one of the challenging parts because of the way the holes were placed on the shaft, and also while making the assembly, one of the holes did not align with parts from other assemblies in order for flywheel to move, so we had to redesign it. So basically the holes were challenging because they were given as section views to us, and so positioning them on a cylinder was a little bit difficult because the dimensions weren't properly done on the drawings that was provided to us. Also, this part has 3 different sets of holes, which were different size than the fasteners and screws, so we had to redesign them as well.
This is assembly 103. It is one of these sub-assemblies for assembly 105 that I was speaking of earlier. As you can see, it's a little bit easier to tell with less parts in the actual picture. These fasteners are the fasteners that we extended. It wasn't necessary, but there's plenty of room in there to allow longer fasteners. We do not know the original designer's intent, but we respected it as best as we could while making making an improvement to the design. And for this assembly 103, it is comprised of the cylinder top, horizontal beam, cylinder fastener, and the hex bolt fastener, which the hex bolt fastener is the one that we increased. Also, assembly 104 is very similar to 103. It's just almost a mirrored part. They fit together to form the main components of assembly 105. Similar to 103, it's created with a combination of the cylinder top, vertical beam, cylinder fastener, and the hex bolt fasteners. As I forgot to mention, the M6x8 hex fasteners. Oh wait, those were the fasteners that I mentioned earlier. I remember in another part I almost had to change the M6 to M8, but disregard.
In conclusion, the project goals were achieved. The main goal of the project was to design the steam engine in CATIA as per given drawings. Even though we had some discrepancies because the drawings didn't have enough information for us to draw or like to create the part. Our instructor was quite helpful to figure it out, to help us figure it out, and ultimately help us achieve the goal. Uh, as a team, we worked really well. We had really well work balance with using fishbone diagram. So both of us maintained the deadlines and tried to finish the project earlier than the desired deadline. One of the strengths was, as I said, it was a good team, and we worked well individually and together with our parts. We were able to work extensively together on the project planning deadlines. One of the weaknesses that we had, or that we figured out while doing this project, was that we were still under the learning process, and we were still learning the workbenches in CATIA, so there were certain mistakes in the drawings, or there were certain mistakes in our assemblies that we were not able to figure out earlier, and so it contributed towards taking more time in finishing the project and doing the drawings completely. Improvement considerations for future projects. I think a team should ask for more critiques from the instructor in order to broaden the scope of improvement in our project. The critiques help in learning not only the project but also learning the workbenches and stuff better. And I hope you like the project. Thank you.